Hello everyone, this is Akash and I am going to present my machine learning capstone project called Credit Card Default Prediction. So let's start. Content in our project: business understanding, data summary, feature analysis, exploratory data analysis, data pre-processing, implementing algorithms, challenges, and conclusions. Business understanding. In today's world, credit card have become a lifeline to a lot of people. So banks provide us with credit cards. Now we know that most common issue there is in providing these kind of deals are people not being able to pay the bills. These people are what we call defaulters. Credit card default happens when you have become a severely delinquent on your credit card payments. Missing credit card payments once or twice does not count as a default. A payment default occurs when you fail to pay the minimum amount due on the credit card for a few consecutive months. Objective of our project is to predict which customer might default in upcoming months. The research aims at developing a mechanism to predict the credit card default beforehand and to identify the potential customer base that can be offered various credit instruments so as to invite minimum defaults. Data summary. Feature summary. X1 is amount of credit, includes individual as well as family credit. X2 is gender. X3 is education. X4 is marital status. X5 is age. X6 to X11 is history of past payments from April to September. X12 to X17 is amount of bill statement from April to September. X18 to X23 is amount of previous payment from April to September. Y is default payment. Insights from our dataset. This dataset is from Taiwan. In our dataset, there are 30,000 rows and 26 columns. There are no missing values present. There are no duplicate values present. There are no null values also. And finally, we have default payment next month variable which we need to predict for a new observations. 9 categorical variables present. 6 months payment and bill data available. The columns are ID, limit balance, sex, education, marriage, age, pay 0, pay 2, pay 3, pay 4, pay 5, pay 6, bill amount 1, bill amount 2, bill amount 3, bill amount 4, bill amount 5, bill amount 6, pay amount 1, pay amount 2, pay amount 3, pay amount 4, pay amount 5, pay amount 6, and defaulters age bin. Analysis of dependent variable. As we can see from above graph that both classes are not in proportion and we have imbalanced data set. We need to do normalize the data in next step. SMOT. SMOT is synthetic minority oversampling technique. Oversampling is one of the most commonly used oversampling methods to solve the imbalance problem. It aims to balance class distribution by randomly increasing minority class, example by replicating them. After performing SMOT operation, we get this balanced dataset. Analysis of sex variable. 1 is male, 2 is female. Number of male credit holder is less than female. It is evident from the above graph that the number of defaulters have high proportion of males. Analysis of education variable. 1 is equal to graduate school, 2 is equal to university, 3 is equal to high school, and 0 for others. From the above left side plot, we can say that more number of credit holders are university students, followed by graduates and then high school students. From the right side plot, it is clear that those people who are other students have higher default payment with graduate and university people. Analysis of marriage variable. 1 is married, 2 is single, and 3 is others. From the above data analysis, we can say that more number of credit cards holders are single. High defaulter rate when it comes to others. Analysis of age variable. From the above count plot analysis, we can say that we can see more number of credit cards holders age are between 26 to 30 years old. Age above 60 years old rarely uses the credit card. Analysis of age variable. From the above bar plot, which shows the relationship between age and defaulter, we can say that those who defaults are 60 years and older, that maybe they don't use their credit card frequently. Analysis of limit balance variable. From the above plots analysis, we can say that maximum amount of given credit in NT dollars is 50,000 followed by 30,000 and 20,000. Checking of correlation. Then model building, logistic regression, random forest, SVC, and XG boost. First one, classification report anatomy. Precision indicates the proportion of positive in identification model predicted class which were actually correct. A model which produces no false positive has a precision of 1.0. Recall indicates the proportion of actual positive which were correctly classified. A model which produces no false negative has a recall of 1.0. F1 score, a combination of precision and recall. A perfect model achieves an F1 score of 1.0. Support the number of samples each matrix was calculated on. Accuracy, the accuracy of the model in decimal form. Perfect accuracy is equal to 1.0. Macro average, short for macro average, the average precision, recall, and F1 score between classes. Macro average doesn't class imbalance into efforts. So if we have class imbalance, pay attention to this matrix. Weighted average, short of weighted average, the weighted average precision, recall, and F1 score between classes. Weighted means each matrix is calculated with respect to how many samples there are in each class. This metric will favor the majority class, will give a high value when one class outperforms another due to having more samples. Logistic regression. The accuracy on test data is 0.65. The random forest and the accuracy on the test data is 0.79%. Support factor classifier is SVC. The accuracy on test data is 0.59. XG boost. The accuracy on the test data is 0.74. And then we are making a API flask for ML classification model. And there is credit card defaulter prediction. Demographic data is gender, then education, marital status, age, limit balance, and behavior data, repayment status, bill amount, and previous payment. And last one, there is the option of prediction. Challenges. Large dataset to handle, feature analysis, need to remove outliers, feature engineering, getting a higher accuracy on the models, carefully handled, feature imbalanced data, carefully tuned hyperparameters. And last one, conclusion. Recent 2-month payment status and credit limit are the strongest default predictors. Recall is the best accuracy matrix here because if the algorithm will not detect the defaulters, that will encounter more loss to the bank. XGBoost provided us the best result, giving us a recall of 74%, meaning out of 100 defaulters, 74 will be correctly catched by XGBoost. Random forest also have good score as well, but leads to overfit the data. Logistic regression being the least accurate, which a recall of 65%. Higher recall can be achieved if low precision is acceptable. This model can only be served as an aid in decision making instead of replacing human decision. Model can be improved with more data and computational resources. Thank you.